Find all the solutions of the equation z squared plus 1 to the power 4 is equal to 1, where z is a complex number. Okay, now this is an equation of complex numbers. So let's write the equation. So it is z squared plus 1 to the power 4 is equal to 1. Okay. So yeah, if you do the expansion of this, I hope you can see it will be z to the power 8 plus some terms of z plus 1 is equal to 8. So by just looking is equal to 1. Okay. So by just looking at this equation, you should know there should be 8 roots. Okay, there are 8 roots or 8 solutions to this equation. So let's start. So we can say z squared plus 1 would be, let's do a substitution that I think would be helpful. So let's say let m is equal to, say, z squared plus 1. So this means, can we say that m to the power 4 is equal to 1, which implies m1 is equal to 1, which is the fourth root of 1, which is 1. Okay, so you can say m1 is 1, m2 would be at an interval. I hope you know the argand diagram. So what we're saying is there are 4 roots here. So if one root is, say, 1, if this is your m1, suppose this is 1, which is m1, the other root would be, if there are 4 roots, it will be at an angle of 90. Okay, so this, what can we say? So the other root, so can we say this is your real arm and this is the imaginary arm. So the other root is I, this is, say, minus 1, and this is, say, this is minus I. This is minus I. So you can say m2 is I, m2 is I, m3 is negative 1, and m4 is negative I. Okay, so now let us put back what is m1. This implies m1, we know m is z squared plus 1, so we can say z squared plus 1 is equal to 1. So let's take one. So from this I have written this. So m squared plus 1 is equal to 1, which means z squared is equal to 0. So which implies z1 is equal to z2. So let me write, there are 2 roots here, z1 and z2, both are equal to 0. So from this you're getting 2 roots. So let's take the real root. So from this, so let me use a different color for each root. From this, we know m is z squared plus 1. So from this we can say z squared plus 1 is equal to minus 1. Okay, so taking away 1 from both sides, so z squared is equal to minus 2. And minus 2 can be written as 2i squared. 2i squared, because I is square root of negative 1. Square root of negative 1, and so I squared is negative 1. So this is basically, this is 2 times negative 1, and this is what is 2i squared. So your z3 is square root of 2i, and z4 is minus square root of 2i. So these are your 4 roots. Okay. So I want you to think about the other roots. So the other root, so you can pause this video. I'll pause this video and come back because I want to use the same space. Okay, so we saw that if m1 is 1, you can write m1 as z squared plus 1 and you get two roots, which is z1 is 0 and z2 is 0. And if m3 is equal to -1, we can get two roots, which is root 2i and minus root 2i. I want to write this in polar form. So writing this in polar form, I can say, well, z3 is root 2 times I. Now I, you should know, writing this in polar form, this I is same as saying 1 cis, or you don't need to write 1 cis pi by 2. This is 1 cis pi by 2, and this you're going anti-clockwise, so this negative I can be written as 1 cis negative pi by 2. So in calculus you write in radians, so this is negative pi by 2. So this is root 2 times I, and I can be written as cis pi by 2. And z4, writing in polar form, this is root 2 times negative I. So this is same as writing root 2 times negative I. And negative I is minus pi by 2. So you can say this is root 2 cis negative pi by 2. So these are the four roots. Okay, so let's look at the this I and negative I. Okay, so let me use a different color. So let me rewrite. So m2 is equal to I, and we just saw that means you can say z plus 1, z squared plus 1 is equal to I, is equal to I, and that means you can say z squared is -1 plus I. Now this is a complex number. You've got a real arm. This is a real number and this is an imaginary number. Now first thing that we want to do is to write this in polar form. Okay, so let me draw the x and the real. This is the imaginary and this is the real arm. So what is -1? So to say this is -1. Sorry, this is +1. Sorry, this is +1. This is a -1. This is I, and this is negative I. So what does this mean? -1 plus I means a point. This is -1 on the real arm and I on the imaginary arm. So this point is called -1 plus I. And you want to write this in the polar form. So to write this in the polar form, let me draw a. So the polar form, this is the radial distance. This is the radial distance. So this is say -1. So here, if you draw a right angle triangle here, I hope you understand this is 1. The distance is 1 here, and here also it is 1. So this is square root of 2. And if this is 1 and this is 1, this is 45 degrees. This is 45 degrees, so this would be 180 minus 45, which is 135 degrees, which is 135. So writing this in radian form, so I'll go 135 ABC 180, which is 3 pi by 4. So this angle is 3 pi by 4. So to describe this in a polar form, okay, so I'm trying to squeeze the whole thing together. So can I say z squared instead of, so let me rewrite, this is -1 plus I, is same as saying this, the radial distance of this point is √2, so that is √2, and the angle that it makes with the positive arm is 3 pi by 4. 3 pi by 4. Okay, now you want to find two roots. Okay, so I can say z squared, the whole to raise to half would be This is 2 raised to half cis 3 pi by 4 raised to half. So you can say this is your z phi would be using the Dimwav's theorem. So this would be 2 raised to 1/4 cis 3 pi by 8. Okay, 3 pi by 8, and as there are two roots, and the two roots would be at an angle of 180. So the other root will be at an angle of 180 from here. So that means if you go 180 from here, the other root would look somewhat like this. It will be here. Okay, or let me do it another way. Oops. So if you highlight this, oops, I don't want to highlight this. Okay, so basically what I mean is I can't highlight that. So this and the other point would be somewhere here. So Z6 would have the same radial distance. So it will be 2 raised to 1/4 cis 3 pi by 8 plus pi, which is 8 pi by 8. Okay, this is nothing but pi, which is 2 raised to 1/4, which is the fourth root of 2 cis 11 pi by 8. Okay, and finally you have got minus I. Okay, so let's write that. So let me use this green color. So again I can say z squared plus 1 is equal to minus I. Is equal to minus I, which implies z squared is equal to minus 1 minus I. Now you can do this yourself if you write this in the polar form. This is minus 1 minus I. So this will be, you're talking about this point. Okay, so this is 180, this is pi, and this is pi by 4. Okay, so writing in polar form, so I hope you understand. So this is z squared is equal to, it will have the same distance of root 2 cis, how much this will be. This is 5 pi and pi by 4. This is will be pi by 4 plus pi. Okay, pi by 4, because this angle, this much is pi by 4, and this is pi, which is 4 pi by 4, which is 5 pi by 4. Okay, this is 5 pi by 4. Okay, so now you can say Z6, you got Z7 would be 2 raised to 1/4 cis, using Dimwav's theorem, will be 5 pi by 8. 5 pi by 8, and Z8 would be 2 raised to 1/4 cis 5 pi by 8. You have to add pi, which is 8 pi by 8, which is 2 raised to 1/4 cis 13 pi by 8, 13 pi by 8. Okay, which is same as 2 raised to 1/4 cis minus 3 pi by 8, minus 3 pi by 8. So these are the 8 complex roots of this equation, which is so small, but you got 8 roots, and this would be an excellent question at NCA level 3 calculus.